Let's add a helper method to draw our fluids in the world. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. I know that at the end of the previous episode I said that we will work on the energy API. I forgot that I need this very powerful, very useful class, and actually it's completely coming from Turtiworthy, although the concept was out there. It doesn't belong to Turtiworthy, and I think he got most of his code from ChatGPT. Anyway, the thing is that when you want to draw fluids inside the world, for example, as a tank, you want to draw quads. And the order of your drawing matters because if you go clockwise, the face will be shown in special sides. And if you go counterclockwise, it will show on the other side. If you don't want to follow counterclockwise, clockwise order, the only way to support a fluid like that inside the world, inside a tank, for example, would be to make your fluid double-sided. And then it would mean that you wouldn't see anything inside that tank, any design that you have inside the tank. And sometimes in your models, you want to draw things inside the fluid, and it's not really beautiful. To make things work, we need to use clockwise or counterclockwise drawing all the time. It will become confusing for new users of this system really fast. And the goal of this utility class is to take out that problem and make it easier for people to draw it. Let me show you what Turtiworthy has, and then I will talk about it. This is his helper class, and yes, it needs to be that complex. Okay, so there are more than few methods there, and this is how he is using it. You see that just by calling these, he is drawing the top layer of a fluid tank, and then if he wants to, for example, he is just drawing one side only because the other three sides are solid, or if he wants to, he can just simply call the render and get done with it. Although there is something about this class that I don't like. I understand it, but I don't like it. He has this should debug amount. Well, it makes sense when you are designing your fluid in the world. You are working with renderers, and sometimes these magic numbers are not adding up. And trust me, you have to use these magic numbers one way or another. Not exactly the same numbers, but your own numbers. And sometimes you are not sure if the numbers are really correct or not. And because of that, he added this flag so that if he is debugging the amount, the height of the fluid, he will use a fill amount that is using a sine wave. It basically goes from 0 to the top. However, this makes him so that he's not making a static method call, and he needs to instantiate a fluid renderer, as you see on top, and then use it so that if he needs to, for example, he can set the debug flag to true or false. Well, why not adding a boolean at the end and have overloads and have static calls? Anyway, that is why I said it looks like he got his methods from ChatGPT and he didn't sit back and really think about how to make things better and easier. Anyway, the class is nice, the methods are nice. This was the only downside about it. So we will have a public void render. Now, the job of this render is to render a fluid. So we will have a single fluid storage. We call it storage. Then we want the vertex consumer provider. We call it vertex not that long consumer. Then we need a matrix stack. So matrix stack, we call it matrices. And if you wonder where these are coming from, actually at any time that you do real render things on your block entity and other things, you got these from the method calls. So it's easy to get your hand on these two. Then we want the light that is int, so int light, and the overlay that is again int. Then we want the world, so world, and block pause, because again, color of the water will change based on where we are drawing it. Then of course we are drawing things, so we want xy, yy, zy, and x2, y2, z2, and I will break these into separate lines. Then we want to know how many pixels we have in the max height, so float max height pixels. This is regarding into your model. If you ever watched one of my block bench series, you would know that a solid block is 16 pixels by 16 pixels by 16 pixels. So if you want to go one level up in the board, the max height would be 16, okay? And finally, that's it. So here we will call another overload. Let me get that overload first because things are becoming much more interesting now. Here we want int color, and color mode, color mode. And this color mode is what 30 has. Where to put this thing? Because it's just addition, multiplication, subtraction, division, and replace. And it's an enumeration, by the way. And the only thing it's doing is just, let me show it. It's bunch of bit shifting and then plussing or multiplication based on the names, actually. Additions means plussing, multiplication means multiply, subtraction is always subtract, division is obvious, replace just replaces things. So he's just getting RGB colors and doing simple math on it. I will have it somewhere. Unfortunately, it should go into GBase. There is no other way around it. So inside our enumerations, we will have this color mode. And I will start copy pasting because honestly, it's not a big deal. These are the variations that we will have: addition, multiplication, subtraction, division, and replace. Then we have this one. By the way, you can look into the repository if you want to and find everything there. And the link for the repository is inside Discord, and the link for the Discord is in every video's description. We want a modify color based on the color that we send in and the mode and the modification color. And you see we get this red modifier, green modifier, blue modifier, and alpha. And then we want to modify the color. Now, as I showed you, modifying the color is just a bunch of simple math combined with these bit shifting. If you are wondering where this bit shifting is coming from, it's basically the standard thing. Whenever you have a complex integer that has 4 bytes, each byte is representing one color and one byte is representing alpha. So we need to do the shifting between the bits to isolate each byte and then take out the R, G, B, and A. And you can find this bit shifting everywhere on the web. It's nothing huge and game breaking. However, if I would want to type all of this, I would take 5 minutes, 10 minutes. So that's it. Now that we have changed the base, we need to update few mavens because our fluids not only depends on the base, but also depends on Jiralib and JInventory. And Jiralib and JInventory are depending on the base. So I need to nuke all 3 of them: base, Jiralib, and inventory. Bye-bye to them. And I need to publish the base to Maven and then resync the Gradle for those 2 libraries. And again, sync them, publish them until I get back to the renderer, and I will come back when it's done. Let's start with our fluid render utility. Now, this comes from 3040. However, I'm fairly sure that 3040 had help from ChatGPT because I saw him using it in one case at least. And some part of it is always global knowledge that you can find in wiki pages or anywhere else. So I'm not gonna waste time typing the whole thing because there is at least 500 lines of code, and really it's just time consuming. There is nothing big there. I will explain things as I'm going forward. So the first overload is to render a fluid in the world. So we have a fluid tank. Let's rename this to storage. Then we have a vertex consumer and matrix and light and overlay. Then because the fluid will change the color in the world based on the biome, we need the world, the position, and then float x1, y1, z1, float x2, and this is max height, not max height pixel, and finally the z2. Okay, then we will call another overload of ourselves that accepts a color mode. So let me add that overload for you, and I will explain everything as we go forward. As you see, it's already 120 lines of code, but it's really simple. So this one is a storage. So again, we got the storage, the consumer, the light, the overlay, the world, and the pause, the XY, Z1, X2, max height, Z2, and then a color and the blending mode. Okay. Now things are interesting here. As you see, he's using this debug amount. Let's call this one debug and remove that extra curly braces. Accept it as a flag there because 3040 being 3040 made this class not a static helper. So boolean debug, and I will use the same thing here, debug, and at the end I will send in the debug. However, now I want 2 more overloads, one for this guy that doesn't accept an overlay, and it will call the same thing but false for the debug, and then another overlay for this one that doesn't has the debug. This one again calls this overload, but now we have the color mode and the color. And for the debug, again, we are sending false. So these top ones that I will cut this guy and put it on top, These two will be used in real scenarios. However, when you are designing, you want to be able to do debug things. Let's see what is all about this huge method. Actually, it's not that complex. If the storage is equal null, or the resource is blank, or the amount is less than 0, well, we don't have anything to do. Return. Then we have a fluid variant from the storage, the amount from the storage, capacity from the storage. A fluid percent from the storage, we know all of this from our widgets. Then he's doing this, and I really am against doing this. He is clamping this percent between 0 and 1. In reality, your amount should never exceed your capacity. If for whatever reason you are exceeding the capacity, you are doing something terrible in your block entity logic, and using this clamp here effectively shadows that error, and you may not ever notice that you have an error there. So bye-bye to that. Now this one, if you're in debug mode, means that we are writing the code inside renderer. And when we are writing a code inside renderer, most of the time we are face to face with this situation. We are using fractional numbers, and I will explain where these fractional numbers come from. But the bottom line is that we will have problem figuring, for example, this one for the fluid height, okay? And at that time, we want to have a simple way of debugging things faster instead of going back and changing the container fluid or the amount or anything else. So instead, Turkey has this code. Now, take note, math.sign returns between -1 and 1. And here, for the sign value, he is getting the time of the game, dividing it by 64 to slow things down, and then doing this. Now, in reality, we want to change -1 to become 0. At the same time, we want 1 to remain as 1. How can we do that? The thing is that you can simply use a math. If I plus 1 to -1, it will become 0. But if I plus the 1 by 1, it will become 2. So at both cases, if I divide the result by 2, it will become 0 to 1. However, multiplication is always faster than division. And in rendering, being fast is a needed thing. So we need to be fast. Because of that, if we go with 1 divided by 2, because it's a sum, it's this part. And we want the original value to be divided. Because of that, we have this multiplication. Basically, we get the result of the sine wave, we divide it by 2, and then add 1 divided by 2. But this math is faster than summing to 1 and then dividing by 2. Anyway, now we have the fluid color that comes from the biome. We already are familiar with this from our widget. Then we have this color mode that we can apply, and we already have the enum. Then we want to get the still sprite. Again, we had learned about it in our widgets. Now this is something that we need to explain. When we are drawing a fluid as a plane, we want it to be transparent with calculations of the color. We want it to be one-sided. So when we are looking from the opposite direction, we shouldn't see it. This translucent call is exactly doing that. So we get the renderer for the translucent call. However, Vertex Consumers has all the different render layers in itself. So we isolate this translucent call from Vertex Consumers and we assign it to our own Vertex Consumer. Then we want to calculate how high we should go. Now, this again needs some explanation. When you play the game, you are working with units of blocks. So one block, second block, third block, and let's go on top. So this is right, this is top. Each one of these blocks will have one unit in the world coordinates. So this is 1, this is 2, this is 1, this is 2. However, if you ever looked at the F3 screen, you see that coordinates are not as simple as integers. They have float fractional precision. The reason is that when it comes to rendering, things are different. Each single block is 16 pixels by 16 pixels. And in the world coordinates, actually, this will be 16 sub-coordinates by 16 sub-coordinates. So when we are working with renderer, instead of this coordinate system, we are working with this sub-coordinate system. Because of that, if we want one block height, we are actually 16 pixel height. And because of that, we need to divide it by 16. And this is the whole magic behind all of these fractional numbers. Because we need to know how many pixels we are inside the block in each direction. And to do that, we need to divide the width of the block, or the width we want to draw something, by 16. Don't worry, in main series we have covered it, so if you don't know what I'm talking about, just go there and watch the video. I will cover it there. Anyways, multiply the fill percent by the max height. That's a standard calculation, and then we divide it by 16f to get into this subspace coordinates, and finally we add it to y1 and we get the final height. Then we want to push the matrix and at the end pop the matrix. Anything that happens between these two calls remains between these two calls. For example, if we are doing multiplication, means that we are rotating the matrix. When we are going out of the matrix, it will flip back to the standard default coordinates. So Minecraft will not be affected. If we forget to do the pop matrix, then things will become ugly. Tons of error calls and sometimes the crash. And if no error calls and no crash occurs, then things will be funny and your Minecraft world may not draw properly. Although I think Minecraft avoids it, but it will constantly yell at you. Your console will fill up with constantly popping up errors. So keep in mind that you should have a matrix pop and matrix push. And I got into the habit of putting an indent here using tab, so that this guideline will help me seeing where the matrix push is starting, and at the end I should have this matrix pop. Now, this is the reason I said that I think this code come from ChatGPT, and I think that Turti didn't review the code, or he may not went deep into reviewing, because right now we are rotating the whole coordinates around by positive x direction using degrees of 180. So basically we are flipping the whole world. Okay, and we are asking if we are lighter than air, then we are flipping back again. This doesn't make sense. If we are not lighter than air, we can do the flip, and just like that, because if we are lighter than air, flipping 100 degree once and then flipping 100 degree again, both on positive x, means that we are ending up in the same place to begin with. So why double call on that matrix multiply? And as I said, when it comes to rendering, optimization is critical. Anyway, now we get the first entry inside matrices. That is related to Minecraft. Don't worry about this. Just know that we got the first matrix that is available to us. Now, this part is interesting. Normally, a light has a luminosity provided by the world. However, fluids may have their own luminosity, and because of that, we remove the luminosity from the color using this bit shift. We get the luminosity of the fluid variant. Then using bit shifting, we give this luminosity to this light and get the final result as the final light. Finally, this is our method calls to draw everything. As you see, we are drawing a XY plane for the front, XY plane for the back, YZ plane for the left, YZ plane for the right. The difference is that sometimes we go clockwise, sometimes we go counterclockwise, effectively flipping the face 100 degree again. These three last values are related to normals. A normal is a vector that is perpendicular to your face, and it's actually telling the system which direction the face should be visible from. As you see, sometimes it's -f, sometimes it's 1, and honestly, I'm fairly sure that this code came from ChatGPT, because I had seen him using ChatGPT to figure the reverse order. And if it was written manually, you would never go with negative values on the normals. That is a little bit of something that I don't like, but I know this code works because, well, I have seen the streams and it's working, so I will stick with that. Instead of trying, erroring, and figuring things out, I will just use the code that is provided by Lord ChatGPT. And no, I didn't do it. Turti had done it. Blame him if you want. Anyway, after these 4 calls, we should have 4 borders vertically around our block. However, if we are not full on the fluid tank, then the height will be lower than the full block. Because of that, we need to put a cap on top of it. And if we don't do it, things will be ugly in the world and you will see 4 different faces. It's not really beautiful. Because of that, we are checking if we are less than 1 for the fill percent. Then we draw the top quad to fill that gap horizontally. Now, one thing, you notice that sometimes we are adding a fraction to z, sometimes we are subtracting it, sometimes we are doing it on the x. The reason is that we want to squeeze this cube inward with that fraction. This fraction will prevent us from having Z fighting. That's all to it. If you want to know what Z fighting is, I had demonstrated that Z fighting in my Blockbench series. Also, you can find lots of information in Wikipedia or anywhere else. Anyways, now that's being said, we can move on and have our next method. This method is when you want to draw just the top cap, that horizontal face on top of everything, and you are not worried about the sides. Maybe your model needs only a horizontal demonstration of fluid. And yes, there are models like that in the modding world. So again, we are accepting the things, but here, notice that instead of a storage, Turkey had simplified things and used a fluid variant. The reason is that normally you want to draw one single type of fluid on the top, and you're calling this from your renderer. So you will have your fluid variant from your block entity somehow. And yes, we could use the storage as a single fluid storage and then get the variant from it. To be consistent, let's do that. Single fluid storage, let's call this guy storage. And again, we will have another overload that will have these two. This time, we don't need that debug thing because, well, we are just drawing something horizontally. So we will have these, but at the end, we will have two more things, integer color and the color mode. And again, I will do the magic of copy pasting because again, we are face to face with few lines of code actually, but I need to change it right now. So we will say if the storage equals null or the storage.resource is blank or the storage.amount is less than 0, return. Then we want the fluid variant. So fluid variant, and we call it fluid variant equals to storage.resource. Again, we check if the fluid variant is equals null, we return. Now, 30 sending a fluid variant is just bypassing these few lines, honestly. Anyway, now that we have the fluid variant, guess what? We are getting the color again. We are getting the sprite, same stuff. Then we are getting the vertex consumer for translucent call again, same stuff. Then we will push the matrix and pop the matrix and do the magic in between. And let's indent them. So we can rotate. And again, I don't understand this code. Why not do this instead? So if we are lighter than air, flip around. Then we get the entry from matrices again. Then we are handling the luminosity. And finally, draw the top quad again. Finally, time for the interesting parts when we are drawing these quads. And this is exactly why I started copy pasting instead of typing. Are you ready? 192 became 253. 40, 50 lines of code actually, I think. No, 40. Anyway, the thing is that we are accepting a vertex consumer entry, the XYZ, and then X2, Y2, and then the sprite, the color, light, and overlay. So we will calculate the tile size because again we are drawing fluids, and if we don't do this crazy math to draw tile based images, we will squeeze and stretch the fluid. And I'm not really sure where did Turti got this code from. Maybe it's from another mod, maybe it's ChatGPT, and maybe he had done it himself, and God bless him if he had done it himself because this is a very crazy math. So to do this, let me explain things first. Let's say that we want to draw a fluid this width, okay? But our texture will be just that. So we need to tile this texture over and over, and at the end, we may want to draw a fraction of texture, and this can happen both horizontally and vertically. So we need to know how many tiles we should draw, how much remaining we have, and how much of a tile we should draw at the end. And this whole calculation and crazy thing from here to here is all about that. So we say that by default the tile size is 1, and then we want the tile count on X, and because we are drawing on the Z direction, the count for Z, and it can be Y and Z, who cares? Then we have to calculate the max number between the math and getting the difference between the X values that we sent in divided by this tile size. Now, take notes, it says maximum tile size in world space, and it's 1.0f. It's a fixed number, and I don't see it being changed anywhere in the code, and dividing anything by 1 will remain 1. So it's just being used in these two cases, by the way. Again, this is why I'm saying that he didn't do this himself, and this is Lord GPT. Why divide by 1? 1, for God's sake. You are not changing it in any shape or any form. Anyway, so we get the difference between x1 and x2, then we rounded it up and then get the maximum number between 1 and that one, whichever is the max. We do it for the x and the z, and this will tell us how many times we need to draw this fluid based on the cubes in the word. So 1 here means 1 cube, by the way. If we have 3 cubes white, then this will return 3 in the x or z, and so on and so forth for the other one. This will be an integer because we want the whole number section of something, because x1 minus x2 may be, I don't know, 2 point something, okay? And as you see, sometimes in his calculations, we end up with something like 1.3 something. So we want this one part, the integer part of this value first, and then by dividing the whole gap by the count, we get the fractional numbers. We first get the u and v for the sprite, and then we want to check the size of each tile. So tile u size is u1 minus u0. Tile v size is that. Finally, we loop for the x number of times we need to draw and the z number of times we need to draw. Then we get the start being x1 plus the number of tiles that we go forward, and end is actually the start plus the width. Same goes for the z, and then we get the end u and v based on the size of tiles. And finally, here is how we draw things. In a vertex consumer, and remember that vertex consumer came up by using a render layer, we need to add 4 vertices. So let me explain this one. Each plane that you draw in the work will have 4 corners. Each one of these corners is called a vertex. In 3D applications like 3D Max, Maya, and etc., people are really familiar with the word vertex. So these 4 vertices needs to be adjusted inside the vertex consumer. The moment vertex consumer has 4 vertices, it will draw a quad. Now, if you go counterclockwise, you will see the face from the direction you are looking at. If you draw it clockwise, it will flip around and you will see the face from the other side. Sometimes it's useful because, for example, I'm drawing the face that I'm looking at, and then I want the other side of the cube. If I don't go the other way around, it will face toward me, but I want to face it to the opposite side, because when I rotate the cube and look around the other direction, I want to be visible from that direction. It may be a bit confusing explaining it, but if you imagine a cube, let me take the block bench. That's the easiest way to explain things for you. Let's say that we have a cube. Right now I'm looking at this red face. If I draw it counterclockwise, it will be visible from here. But if I draw it clockwise, then it will be visible from this direction. So here it will be invisible, here it will be visible. Now, when you are drawing a tank, for example, you want to draw this face counterclockwise. Then you want to use the same coordinates offsetted by one direction and draw the other side. So if you are using counterclockwise here, you want to use clockwise here, so that when you move around the cube, it will become visible from this direction. I hope that made sense. So here is the draw quad. This will go, I think, clockwise, and all he's doing is actually assigning the 4 vertices. So we start with the x that is starting, the y that we start, the z that we start. That's our first vertex. Of course, we are assigning the color, the texture, the light, the overlaid, and normal. Then we will go on the other direction, and then we assign the second vertex from the start. But you notice that instead of z start, we go with the z end. Then we go toward the x end, z end, and then we come back to z end and z start. And if I want to follow that, we will end up with x start, z start. So it's an xz plane. That's it. That's how you draw the top quad. And because of the top quad being top quad, we are just using y in every one of these. And it was our bias because we are just moving toward x and z directions. Basically, let's say that we are looking from top to bottom, and this is the top face. This is x start, z start. Then he goes to x start, z end. Then he goes to x end, z end, and he comes back to x end, z start. So if we continue back, we are ending up with x start, z start. This is our first method to draw the quads. We need more because this was the top part. Now we have another one that will draw the XY quad only, and I will move through things faster this time because I had explained enough. We need a fluid storage here. We call it storage. Again, we are expecting everything as before, so I'm not going to explain anything anymore here. And we are calling another overload. This overload is again more than a few lines of code, but the concepts are the same, so it's not worth mentioning anything other than changing this storage to be storage, and it's nullable. So I will take this code from here, paste it on top so that it's compatible with my change of using the storages, and again I will break these so that it's more readable like that. All we are doing again is just doing the whole bunch of repetitive things, and again this is goddamn thing. So we are again pushing to matrix. We are popping the matrix. Everything is the same. The only thing is the different method call here. And now we can draw XY quad, and this is the draw XY quad. Again, this is the whole concept. Again, this is being used more than once this time. Well, divide it by 1, multiply it by 1. Holy moly, do you change it at any time? No. Why? The answer is ChatGPT. Okay, so I need a little bit of cleanup here. And yes, I'm aware that I have a useless parenthesis here, but who cares? I will just go on with this. Here we are adding things. We didn't add things on top, did we? I don't think so, because if it was addition on top, it would yell at me, but it didn't. No, we are just using it there for the division, but here we are adding things. So I will keep it, but the division can be gone and only the additions will be there. Multiplications will be gone. Multiplies 1.0f, that means 1.0f anyway. Okay, finally we are drawing the quad, and this is draw full tiles, and it will draw them. Then we do the leftovers. Now for the top section we didn't do that, but for the horizontal sections we are calculating the leftovers and do them. We draw the leftovers for the y, and we draw the corner leftover tiles if both leftover x and leftover y is still greater than 0. So that's just tile drawing. However, I'm not sure. I think he's actually not caring about stretching the fluid on the top side, maybe, because if he would care, he would have done the same thing here. Anyway, okay, we are drawing 4 quads here because we are drawing the fulls, then leftovers on x, leftovers on y, and then finally we check if we still have leftovers. Again, we draw another pass. Now the rest are almost identical to this one, so let's expand this, and as you see, again we are doing multiplications, divisions, but the addition is here. So just get rid of those divisions by 1, although I think the compiler will fix this, but I really am against doing it. My brain doesn't like it anyway. So that, keep the plus sign there. We are doing it in more than one place. God damn it, you. Okay, let's take a look at that. It's there too. Then the next one is here. Okay, this can be gone. Be careful when you're commenting something like this. This can be gone. This can be gone. And that's it. So here again, we are multiplying here. We are multiplying here. This is addition. We should keep it. Multiplication. Multiplication. Good. Okay, then another quad. Now take note, this one was YZ. Previous one was XY. Now we are going in YZ direction. And these were the straight ones. We want another one that is just this draw quad method. So finally, this is where the whole magic begins again, and we should be able to see vertex consumers. And that's it. We're just assigning 4 different vertex consumers. All of these happened clockwise. Now we have counterclockwise for all of that. So let me put a comment here so that I know where I'm adding these things. Get ready. 492 became 655. And this part is exactly where I saw him using ChatGPT. He gave the whole method to ChatGPT and asked him to add a reverse call for all of these. And as you see, the things are a little bit different. So it's vertex 4, x, y, z, vertex 3, vertex 2, vertex 1. This is the reverse quad. Then he goes for x, y coordinates. And again, funny enough, ChatGPT being ChatGPT is just repeating the code that he sees. Yeah, this is why you shouldn't trust ChatGPT all the time. You should read what ChatGPT is providing, because if you give him something that is not clean, it will not clean it for you. It will just follow your example and give you whatever you're asking for, and that would be it. So again, here we are doing multiplication by 1, here we are doing division by 1, and just double checking that it's not adding anything to this guy at any time, or assigning it to be a different value anyways. No, it's not doing it. So yeah, a little bit of code cleanup, but it's worth it. Trust me, it's worth it. Because if you want to write this code yourself, be my guest. It's a lot of work to do. So this one was draw quad. It's exactly the reverse order of this thing. So it went clockwise, he goes counterclockwise. This is the XY plane. Then we will have the YZ plane being the same gibberish thing with multiplying by 1 and dividing by 1 all around the place. Another 1 and another 1. Then he comes to this place that is again multiplying it by 1, multiplying it by 1. And finally, we have the whole thing. Again, it's just drawing the face first, then the leftovers, and then one final check for the leftovers and drawing it again. So that is the whole thing. Finally, this helper method is done. I know that it was a bunch of copy pasting, but honestly, it's just calculating coordinates based on the pixels and then UV maps. The real magic here is this dissection of your coordinate to be tile sized, and then looking for leftovers on Z and leftovers on Y, and figure out that which direction should use the leftovers. There's nothing special other than these here. And honestly, if you want to, well, Turtivorti has his own repository. My repository is there. You can take a look at them, or alternatively, you can just use the library as it is and have fun, because Lord GPT has done most of the heavy lifting here. I'm sure of that. Okay. Anyways, this is our render helper for rendering the fluids inside the world. I think by doing that, finally we finished the fluid API for ourselves, the JiFluid one. And in the next video, finally, I can go back and have fun with energies. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.